function and check for stationarity. The results of the Dickey-Fuller test show that the test statistic is less than 1% of critical value. That tells us that we are 99% confident that this series is stationary. We can reject the null hypothesis. Great! We have now seen how to explore and examine the time series data. Let's quickly recap the steps we covered. 1. Perform exploratory data analysis. 2. Perform decomposition of data. 3. Perform stationarity check. Series models, Part A. There are many ways to model a time series in order to make predictions. The different models are autoregressive or AR model, moving average or MA model, autoregressive and moving model or ARMA model, autoregressive and integrated moving model or ARIMA model. Let's look at each of them in detail. An autoaggressive AR model predicts future behavior based on past behavior. It's used for forecasting when there is some correlation between values in a time series and the values that precede and succeed them. You only use past data to model the behavior, hence the name autoregressive. The process is basically a linear regression of the data in the current series against one or more past values in the same series. The AR model is defined by the equation shown here, where yt is the different past values of the same variable, et is the error term, c is the constant, phi p is the parameter. AR1 is a model whose current value is based on the preceding value. AR2 is based on the preceding value of two values. A moving average model uses past forecast errors in a regression-like model rather than using past values of the forecast variable in a regression as seen here, where epsilon t is white noise. Notice that each value of yt can be thought of as a weighted moving average of the past few forecast errors. There is a difference between moving average models There is a difference between moving average model and moving average smoothing, so don't confuse these terms. A moving average smoothing is used for estimating the trend cycle of past values, while a moving average model is used for forecasting future values. In MA model, the error terms are assumed to be white noise processes with mean zero and a constant variance. Time series models, Part B. ARMA model is simply the merger between ARP and MAQ models, as shown in the equation given. ARP models try to explain the mean and momentum reversion effects observed in trading markets. MAQ models try to capture the shock effects observed in white noise terms. ARMA model attempts to capture both of these aspects when modeling financial time series. It refers to ARMA of P and Q, where P is the autoregressive term and Q is the moving average term. An ARIMA model is a class of statistical models for forecasting, analyzing time series data. It explicitly caters to a suite of standard structures in time series data and as such provides a simple yet powerful method for making skillful time series forecasts. It is a generalization of the simpler autoregressive moving average and adds the notion of integration. ARIMA refers to ARIMA of P, D, and Q, where P is the autoregressive term, D is the order of differencing, and Q is the moving average term. If no differencing is done, the model is usually referred to as ARMA of P and Q model. Time Series Models, Part C. It can be helpful in data analysis and modeling to understand the relationships between variables in a better way. Correlation is the statistical relationship between two variables. A correlation could be positive, meaning both variables move in the same direction, or negative, meaning that when one variable's value increases, the other variable's value decreases. Correlation can also be neutral or zero, which shows the variables are not related to each other. Let's understand autocorrelation function and partial autocorrelation function. Serial correlation or an autocorrelation is the correlation of the time series observations calculated with values of the same series at previous times. A partial autocorrelation is a summary of the relationship between an observation in a time series with observations at prior time steps with the relationships of intervening observations removed. Autocorrelation function will identify the order of MA process, and partial autocorrelation function will identify the order of the AR process. Autocorrelation and partial autocorrelation functions are used to determine the value of P and Q. Let's see the characteristics of autocorrelation and partial autocorrelation function with respect to AR, MA, and AR-MA model. Autocorrelation function in AR model spikes decay toward zero, whereas partial autocorrelation function spikes cut off to zero. In AR-MA model, both autocorrelation and partial autocorrelation functions spike decay toward zero. Now let's understand the steps involved in time series forecasting. The first step is to visualize the time series, that is, check for trend, seasonality, and random patterns. The second step is to stationarize the series using decomposition or differencing techniques. The third step is to plot autocorrelation and partial autocorrelation function and find P, D, and Q parameters. The fourth step is to build an ARIMA model. And finally, the fifth step is to make predictions using the ARIMA model.